Alright, number 1. We're supposed to graph. They want us to give at least 2 points. I'll probably do 3. So growth or decay. I see the B, the base number is 4, which is larger than 1, so it's growth. 2 points. Instead of filling in that blank, I'll probably just make my little chart. I'd rather do that. I might do some of these other questions first, though. Transformations, it's going 1 to the left. It's going down 2. So horizontal asymptote, it's a horizontal line, so it's going to be a y equals equation. So y equals whatever our k is, which is -2. Domain is all reals. The range, it's going to be opening down, so it's going to be y is less than the asymptote of -2. So, okay, my h value is a -1, so I'm going to use -1, and then I'm going to surround that. So when I plug in -2, my x becomes -1, so it's 1/4. So -3/4 when I multiply, -3/4 minus 2 is -2 3/4. Or -2.75 when I plug in -1. Exponent becomes 0, 4 to the 0 is 1. Times -3 is -3, minus 2 is -5. When I plug in 0, I get an exponent of 1. 4 to the 1 is 4, times -3 is -12, minus 2 is -14. I'm not going to go that low on my graph, so I guess I will only graph 2 points. It's a -2, -2 and 3/4. Be about there. -1, -5. And so I've got I can't touch across my asymptote. And you see it's growing, it's growing down because of the a value was negative. So there, I guess I filled out everything. Next problem, that's less than 1, so it's decay. I could have also said on the transformations, I probably also should have said flipped since that a value was negative. Flipped across the x-axis, I just don't have that much room. Back to this one, transformations, this one's going down 4. So horizontal asymptote is y equals -4. Domain would be all reals. The range, this is going up, so y is greater than our -4. Table of values. -1, 0, 1 are what I'm going to plug in. So plug in -1, I get 3 minus 4 is -1. Plug in 0, so I get 1 minus 4 is -3. And then plug in 1, 1/3 minus 4. I'm going to have -3 2/3. So asymptote at -4. -1, -1. 0, -3. And 1, -3 2/3. Now starting with numbers 3, or starting with 3, we've got logarithmic equations. So transformations, this one's going to right 3 up to vertical asymptote. It's going to be an x equals equation, so x equals h, which is 3. So my domain is going to be x is greater than that, greater than 3. Range will be all reals. It flips because it's a logarithmic. Okay, so table of values. So I'd like to end up taking log base 4 of 1/4 and of 1 and of 4. 2 of those are easier to get than the other. To get to 4, I want x to be 7. To get to 1, I want x to be 4. To get from 1/4, I have to subtract away 3, so it'd be 3 and 1/4. So if I plug those in, 3 and 1/4 minus 3 is 1/4, so log base 4 of 1/4 is -1, plus 2 is 1. Plug in 4, log base 4 of 1, that's 0. Plus 2 is 2. Plug in 7, log base 4 of 4, that's 1, plus 2 is 3. So 3 and 1/4, about there, 1, 4, 2, and then after that 7's off my graph, so I'm not going to graph that one. So our graph looks something like that. This one, there's no transformations. Vertical asymptote is x equals 0. Domain would be x is greater than 0, and the range would be all reals for table of values. There's no shifts, so I can plug in 1/2, 1, and 2. So log base 2 of 1/2 is -1, log base 2 of 1 is 0, and log base 2 of 2 is 1. My asymptote is right there. So 1/2, -1, 1, 0, 2, 1. Alright, let's move on from the graphs now. We're an exponential function. So we know this is our a value, our initial value. This is just going to be an x and a y until we figure out what our b is. We'll use the equation y equals a times b to the x. So 81 is equal to my initial value times b to the x power to the 4th power divided by 256. So I take 81 over 256, and then I'm gonna, let's see, that I'll have b to the 4th equals that. Let me rewrite this. We have a little more room. B to the 4th equals 81 over 256. And so then I'm going to be taking the 4th root. Normally I would do plus minus since it's an odd number, but b has to be positive, so I don't have to worry about it. So I'm going to do the 4th root of the top and the bottom. 4th root of 4th root of 81 is 3, and the 4th root of 256 is 4. So I've got y equals, my a value was 256, my b value is 3/4, that's to the x power. Number 6, so here's our a, there's an x and a y, so 21609 is equal to 144 times b to the 4th power. So we're going to divide by 144. Looks like that fraction's probably going to simplify. Okay, it becomes 2401 over 16. I'll be taking the 4th root of that. So the 4th root of 2401 is 7. And then the 4th root of 16 is 2. So our equation, y equals 144 times 7 halves to the x. Number 5, they're both powers of 8, so I'm going to change 64 to 8 squared. Multiply my exponents, 6x. So now I know my exponents must equal each other. 6x must equal 2x minus 3. Subtract 2x. 4x is equal to -3. So x is -3/4. Here we're going to have to go for powers of 4. It looks like we could go powers of 2, but powers of 4 work, so we have got 4 squared to the x. 64 is 4 to the 3rd, so to bring it out of the denominator, make the exponent negative. So 4 to the 2x equals 4 to the negative 3. So then 2x has to equal negative 3. So x has to be negative 3 halves. I can write these as powers of 9. So it's 9 squared, 9 to the negative 2 then to bring it up. Distribute that exponent, negative 2x minus 4. So x minus 2 has to be greater than negative 2x minus 4. Add 2x and add 2. Divide by 3. Looks like x is greater than negative 2/3. Write in exponential form, that would be 2 to the negative 4 equals 1/16. Write in logarithmic form, that'd be log base 10. Since it's a base 10, you don't even have to write it. It could just be a common logarithm. But log base 10 of 100 is equal to 2. You evaluate. 4 to the 4th is 256, so I know my answer is 4. 2 to the 3rd is 8, so 2 to the negative 3rd is 1/8, so negative 3 is the answer. Alright, solve. Excuse me. So I can rewrite, I can exponentiate. We end up with x is equal to 4 to the 3 halves. And so it's a square root of 4, which is 2 to the 3rd power, so I get 2 to the 3rd, which is 8. That fits in the domain. Here I can draw both logs, so I know x squared minus 18 has to equal negative 3x. I'm going to add that 3x over. Attempt to factor this. 6 and 3, x plus 6, x minus 3. So then I get x equals negative 6, and x equals positive 3. But then I want to consider, actually when I use 3, negative 3 times 3 would be negative 9. That one's not okay. Negative 3 times negative 6 will work. Negative 6 squared minus 18, that was going to work. So x equals negative 6 is the only answer. Here I can draw up the logs. We're going to have to be careful since it's an equality, we'll have to check the domains. But I already started with this, let's continue. Subtract the 2x, add the 6, divide by 2, so x is greater than 7. Let's check and see what our domains were. We know that the 4x minus 6 had to be positive. And we also know that the 2x plus 8 has to be positive. So let's consider both of those things. So 4x is greater than 6, so x is greater than 3 halves. I don't know why I wrote equals greater than 3 halves. And over here, 2x is greater than negative 8, so x has to be greater than negative 4. So in order for both of those conditions to be met, to be greater than both negative 4 and 3 halves, has to be greater than 3 halves. And then does x fit into that? Yes, if x is greater than 7, that does fit into the greater than 3 halves. So that works. Number 15. Here we've got to condense those two logs together. So you have to take the x times the x minus 4, distribute that, so you get x squared minus 4x. Okay, drop the logs. X squared minus 4x equals the 5. Subtract the 5 over. X squared minus 4x minus 5 equals the 0. X minus 5. X plus 1. So x is equal to 5, and x is equal to negative 1. Negative 1 we get to throw out. So x equals 5 is our only answer. Alright, here we do the same thing. Since it's a basis of 10, it's just common log. I don't even need to write the 10, so I'm not going to bother. So we have z squared plus 9z. Here I'm going to exponentiate, so just take 10 to both sides. 10 to the left equals 10 to the right, so I end up with z squared plus 9z is equal to 10 to the first, which is 10. Subtract that over. 10 squared plus 9z, or sorry, z squared plus 9z is equal to negative, I don't know why I wrote equal to. I meant to subtract that 10 over. Minus 10 equals 0. So factor, I don't know why I wrote x, should have been a z. Z plus 10. Z minus 1. So z is equal to a negative 10 and a positive 1. Negative 10 we can throw out. Looks like the 1's going to work, so z equals 1 is the answer. And then for number 17, so log base 6, have to distribute, so we've got x squared plus 5x is equal to 2, so now we can exponentiate, so 6 to the left equals 6 to the right, so I get x squared plus 5x, and 6 to the second is 36, so subtract that over. Looks like I'm going to have to go with a 4 and a 9 when I factor this, so x plus 9, x minus 4, so x equals negative 9, positive 4, we can throw out the negative 9, it's not going to work, so 4 is the only answer, x equals 4. Number 18. Since it's a base of 10, I'm not going to bother with the base. It's going to be 18 over 3x. This, I forgot the 2 there. It just said log base 10, which doesn't make sense. Should have been log base 10 of 2. Sorry about that. So log of 2. 18 over 3x simplifies to 6 over x. I can drop the logs on both sides. So 6 over x equals 2. Or if you want to put those 2 over 1s, you can cross multiply. Cross products, 2x equals 6, so x has to equal 3. It looks like number 19 we're going to log both sides, so I'm going to write log in front of the left side. And when I do that, the x plus 1 comes out front. Can divide by log of 8. Actually, let's see. And subtract the 1. So we're going to try log of 30 divided by log of 8. And then we'll subtract 1 from that. You get an answer of 0.6356. Okay, and so then same thing on number 20, we're going to log both sides. And so then I can move that x squared out front. And then I'm going to square root after that, so I'll get to do plus minus. So x equals a positive or a negative. And let's check out the square, whoops, I didn't mean to go there. Okay, square root of log of 28 divided by log of 6. So x is a positive or negative 1.3637. Alright, number 21. So now we've got an inequality. I'm going to log both sides. So the 4x will move out front. I'm going to divide by the log of 3, but I'll also divide by 4 at the same time. That way the 4's cancel and the log of 3's cancel. So x is less than. So I'll do log of 72 divided by, I need parentheses around the denominator since there's two things there, 4 log 3. So I get 0.9732. Alright, so then number 22, I'm going to add the 11 first. I'll divide by the 4 next. And then we're going to ln both sides. Ln, slide it in front of both of those, and maybe give myself a little more room here. So that was a 7, but I'm going to put an ln in front of it. So on the left side I just get x equals ln of 7. So let's type in ln of 7 on the calculator. I get 1.9459. Number 23, I'm going to add that 5 over. Divide by the 3. I'm going to be ln'ing both sides, so I'm going to leave room for, or just go ahead and do that ln, but I divided by 3, so I have 1/3. So I'll have 2x equals ln of 1/3, and I'll divide that by 2. So I'm going to do ln of 1/3 divided by 2. So x should be negative 0.5493. I didn't necessarily give myself enough room. Let me try this again. Negative 0.5493. Sorry, I'm just wanting to make sure I got that right. Okay. Let's see. I want to make sure I didn't make a mistake there. I think I got it right. I just messed up when I was typing it in. 2 times. Okay, yeah, that worked out good. Sorry. I just want to confirm that before I move on in case I made a mistake. Number 24, we're going to subtract the 2. E to the x is greater than 7. I'm going to ln both sides. I should have left room in front of that 7. So x is greater than the ln of 7. Let's type in ln of 7 on the calculator. So we get x is greater than 1.9459. Okay, number 25, I can exponentiate both sides with the base of e. E will cancel out the ln, so I get 2 to the x equals e to the 6th, and then I'll divide by 2. So e to the 6th divided by 2 is 201.7144. Number 26, I'm ready to exponentiate. E to the ln cancels out, I get x plus 3. equals e to the 6th. I'll subtract the 3, so I'll have e to the 6th minus 3. Oops. To the 6th minus 3. Which is about 400.4288. Number 27. 2 years you want to have 5,000. So I don't have 5,000 initially. That's what I want at the end of time. We want to find out what we should deposit. X, Y, B, I mean whatever you want to make that variable. I'm not too concerned about the letter that you use there. The account pays 3% interest compounded monthly. So 1 plus 0.03, it's compounded monthly, so divided by 12. The exponent 12, and then it's 2 years, so 12 times 2. So I'm going to end up, to get X by itself, we got to divide by that whole thing. So I'll have to take the 5,000 divided by 1 plus 0.03 divided by 12 to the exponent of 24. So I'll type that into the calculator. 5,000 divided by, I'm just going to do start a set of parentheses and then a new set of parentheses for the 1 plus 0.03 divided by 12. Close that parenthesis, take it to the 24th. And I'm done with the whole denominator now. 4709. So $4,709 and 17.5 cents. So we'll call that 18 cents. That's what I should deposit if I want it to be $5,000 in 2 years. Number 28. Okay, you deposit $350. It's compounded continuously. So our principal is $350. E to the R, so 0.032 when we change it to decimal. And we're doing 8 years. So 350 e to the 0.032 times 8, 452.11. If you deposit 2,000, 6.4% interest compounded continuously. We want the money to triple, so we want 6,000 at the end. Start with 2,000. Our rate is 0.064. We don't know how much time. We're trying to figure that out. I would start by dividing by my 2,000. So we get 3 equals E to the 0.064 t. So to solve that, I'm going to ln both sides. So ln of 3 is equal to 0.064 t. So I'll divide that by 0.064. So I'll take ln of 3 divided by 0.064. So they see that t about 17 years. It'd be like 17.1 years, but I'll go ahead and call it about 17 years. A radioactive substance has a half-life of 32 years. Find the value of K in the equation of decay. Now for the substance. Sorry. So we're talking half-life. So it initially has A. So at the end of time, at the end of 32 years, it's going to have half of that. So 0.5 A equals A times e to the k times 32. So we're going to start by dividing by a. So 0.5 is equal to e to the 32k. So I'm going to ln both sides to solve that. So ln of 0.5 is equal to 32k. So divide by 32. k-value of negative 0.0217. So find the value in the equation. So for the equation then, y equals a times e to the negative 0.0217 t. So for a certain strain of bacteria, K is 0.728, where T is measured in days. Using the formula y equals A times E to the KT, how long will it take 10 bacteria to increase to 675? So we want to end up with 675. Oh, sorry, it just hit me that I forgot to do a negative here, because that was actually decay. If I would have put the negative there and used that decay model, it would have turned my K value into a positive. And then when I put it in, I still have the negative there. It didn't affect the equation I get at the end, but the K value would have been positive if I would have started with that negative, which is more consistent with what we did in class. Okay, so down number 31, we've got 675 is what we want to end with. We started with 10. We know the K value, 0.728. Can't write 728. And we're trying to figure out what T is. That is measured in days. We're going to divide by 10. I'm just going to leave, even though I could divide them both by 5, I'm just going to leave it as a fraction. I'm going to type it in the calculator in just a moment anyway. Just going to ln both sides now. So ln of 675 over 10 equals 0.728 t divided by 0.728. So ln of 675 over 10, and then we divide that by 0.728. Oops, 0.728. There we go. So we see we'd round that to go ahead and round it to just 6 days.